In section 3.3 in Algebra 2, we've been discussing how to graph the intersection of a system of inequalities, which is another way of saying solving the system of inequalities. Here I've already got 2 lined up for you. Y is less than or equal to x plus 2, and x plus 2y is greater than or equal to 8. To review the steps, first we're going to put everything in slope-intercept form. That makes it easier to graph. And as a reminder, our slope-intercept form is y equals mx plus b. M is our slope, b is our y-intercept. Next, we're going to graph each inequality. That means we're going to shade in on one of the 2 sides of each of those lines. Then we're going to look at the intersection of the 2 inequalities and shade that in even darker. So let's go ahead and get started. When I look at this, I notice that my first inequality is in fact written in slope-intercept form, but my second one is not. So that means that we're going to have to do a little bit of work to get this into place. To do that, I'm essentially trying to get everything equal to y. So I'm going to solve it just like I would as if I were solving for y in terms of x. So I've got 2y is greater than or equal to negative x plus 8. Dividing everything by 2 leaves me with negative 1/2 x plus 4. And that is my slope-intercept form. So I'm going to go ahead and rewrite my inequalities. Now that I've done that, I can go ahead and graph. For the first inequality, I have an y-intercept of 2, a slope of 1. The slope is a change in y over the change in x, so that's up 1 over 1, up 1 over 1. Then I have y is greater than or equal to negative 1/2 x plus 4, y-intercept of 4, and a slope of negative 1/2. That's down 1 over 2. For this first one, the y is less than or equal to x plus 2. With y being less than or equal to that, I'm shading in this region. With my second one, with it being y is greater than or equal to negative 1/2 x plus 4, I'm shading in the upper region. So my intersection is between these 2 areas in the first quadrant. So I would shade in my solution like this. As a reminder, we have quadrant 1, 2, 3, and 4 in our coordinate plane. So this is my solution to this set of inequalities. Any of the pairs, the ordered pairs, within the shaded region and continuing on into infinity would be a valid solution to the system of inequalities.